Hi, I'm Angela Rasmussen from the University of Utah Department of Electrical and Computer Engineering. And I wanted to go over an example now of Fourier analysis. So we are going to look at this circuit given this input. So the Fourier transform of this input for I of s of t, so this is Is of t, is going to be A over t omega squared times 1 plus jt omega times e to the minus jt omega minus 1. So that is a Fourier transform that you can get. And then given that R1 is 500, R2 is 2K, and C is 0.33 microfarad, we want to solve this circuit to get V out of T. So as you know, I like to do node voltage, so I'm going to call this node Vx. This is going to be ground, and doing a node voltage equation here, I get minus Is plus Vx over R1 for this current, and for this current, it's going to be Vx over R2 plus 1 over j omega c. So this gets changed into j omega c, and then that is equal to 0. And so we can combine the like terms to get Vx. 1 over R1 plus 1 over R2 plus 1 over j omega c is equal to Is. And then combining to get, again, the common denominator for these, you get R2 times j omega c plus 1 and then our common denominator is R1 times R2 j omega c plus 1. So here I just multiplied that out to get R2 j omega c plus 1. And so when I do that, the j omega c will go to the top. So that will give us an R1 j omega c. And that's equal to Is and now we can divide, so we get Is R1 R2 j omega c plus 1 all over R2 j omega c plus 1 plus R1 j omega c. So this gives our value of Vx, and we want to find V out. So in order to get V out, we can say that V out is going to equal Vx over R2 plus 1 over j omega c, which is our current, and then we want to multiply it by 1 over j omega c. So that will then give Vx over j omega c R2 plus 1. So when I multiply this on the top, it gives me 1 over j omega c, and then I multiply it on the bottom, and it gives me R2 over j omega c. I'll just write this out, might be easier. It's j omega c. Okay, and then I multiply it by 1 over j omega c, and these are going to cancel. Sorry about that. Okay, so to get the common denominator on the bottom, it's R2 j omega c plus 1, and then the j omega c goes to the top, and then that will cancel with the one you're multiplying by with the 1 over j omega c. All right, so from here we have V out then is equal to Vx and then we divide the Vx by j omega c R2 plus 1. And so these end up canceling. So we can rewrite this as V out is equal to IS. And we can put in 500 for R1, and then 1 plus j omega, and C is 0.33 micro, and R1 plus R2 is 2.5 K, which ends up giving 500 IS over 1 plus j 8.25 times 10 to the minus 4th. J omega times 8.25 times 10 to the minus 4. So that is our equation for V out. And now we need to put IS in there. And so IS is the A T omega squared j omega t. Oh. J omega t minus 1. And so we get V out here is equal to 500A divided by T, and then 1 plus jt omega e to the minus j omega t minus 1 all over 1 plus j omega 8.25 times 10 to the minus 4th. Missing the omega squared. Okay, and then we can separate this out. To e to the minus jt minus 1 all over 1 plus j omega 8.25 times 10 to the minus 4th. I miswrote this somewhere. 1 plus j, okay. So this is 1 plus j omega t e to the minus j, okay. So this is 1 plus jt omega e to the minus j omega t minus 1, okay. Sorry, I got a little confused for a minute because I was like, that's not quite equal. So yeah, e to the minus j omega t is multiplied by the first one, and then you have a minus 1, and then you're going to have omega squared, and then plus j omega t e to the minus j omega t all over the same components, or same element numbers, omega squared. All right, so we note that the e to the minus j omega t, just like in the Laplace, becomes a time shift. And so this will become a time shift. So what we want to do is move that out and then have just the function in w that we want to transform. And so we can rewrite this as v out of omega is equal to 500a over t minus 1, and then some function f1 of omega, and then we'll have the same thing, e to the minus j omega t times, oh, and we can bring the t out because it's a constant, so f2 of omega. And so f1 of omega here is going to equal just 1 over one plus j omega squared, and f2 of omega is going to equal j omega t, and we brought the t out, so j omega over and so from here we need to now do partial fraction expansion. So we'll start with f1. So we need to put this into the terms of an a. And then plus b over omega plus c over omega squared. And so a is going to be this quantity times f1 of omega, and then evaluated at omega is equal to minus, or the root of that. So when I multiply this, I just end up with 1 over omega squared, and then I'm going to evaluate it at minus 1 over j 8.25 times 10 to the minus 4th. So the minus goes in, and then the squared is going to cancel it. And so I end up with the 1 over 1.8, 1 over 1, 8.25 times 10 to the minus 4th brings that up to the top. So that's going to become 8.25 times 10 to the minus 4 squared. And it's going to be a minus number because it becomes squared, but then the j, wait a minute, minus, yeah. So j squared, and that j squared is a minus. And then for b, I'm going to take the derivative. So I'm going to find c first. So c is going to be omega squared times f1, which just ends up 1 plus j omega and then evaluate this at omega equals 0, which gives me 1. And then b is going to be the derivative of that. And so when I take the derivative, the minus 1 from the bottom becomes it becomes squared on the bottom. And so this becomes squared on the bottom. And then I have to bring out the j 8.25 times 10 to the minus fourth. And then I'm going to evaluate it again at 0. So this then is left with just a minus j 8.25 times 10 to the minus fourth. And so now my F1 if I plug those back in, I get the minus 8.25 times 10 to the minus 4 squared becomes a minus 6.81 times 10 to the minus 7th. And then I plug in the other numbers. So I get my F1 of omega looks like this. And now I need to look for F2 of omega. And so F2 of omega, I note here that the W's, I can have one of them cancel. And so I am left with j over 1 plus j omega 8.25 times 10 to the minus 4. So that's going to leave me with, I can just call it A1. And then plus just a B1 over omega. And so now when I find A1, it's going to be this times F2 of omega and evaluate it again at a minus 1 over j 8.25 times 10 to the minus fourth. And so that just is 1 over omega at that. And so that leaves me with a minus 8.25 times 10 to the minus fourth. And then B1 is going to just be omega times F2 of omega. And so that leaves me with the j, oh sorry, this is a j. So the j's cancel, which is why I end up with a minus 8.25 times 10 to the minus fourth. And then on this one, I end up with a j over that quantity evaluated at 0. And so this leaves me just with a j. And so my F2, when I plug that in, I end up with a positive, let's see. I put in a minus and my j's should cancel. J positive 8.25 times 10 to the minus fourth over that plus j over omega. And so if we go back to the V out equation, then I can plug in F1 of omega and F2 of omega, and it will give me this expression. So I take you can pause this and make sure you can go back and plug these back in. What I note here is that now I want to move this to the time domain. So I note here from the transform tables that several of these match up. So 1 over a number a plus j omega is number 7. So this ends up being number 7. And this one is going to just give me a time shift. And this one is going to be over omega, which is if I move this down, the minus j becomes a positive j. And so 2 over j omega ends up being this number 4, which is a sine. So this will be number 4. This part will be a time shift again. This one's going to be a time shift. And this one at omega squared is going to be number 6, which is a minus 2 over omega squared. So that's number 6 in the table. And then this again is going to be number 7. And this one will be, and that's with a time shift because of the EJ minus j omega. So time shift here. And then this will be a time shift of number, let's see, omega was number 4. And again, this becomes a minus j in the bottom to match up with the table. And so from here, I can, so the time shift, when I have that, just goes from f of t, it will then just shift to an f of t minus t0, which t0 will be the value in the shift here. So as I plug those in, I'm going to just copy it because it's a long equation. Move these down a little. All right, so what I notice here is that I have several that have time shifts. So I have this quantity as a time shift of number 7 and this one as a time shift of number 7. So I can combine those as one. So if I do that, I have a minus 1 times a minus 6.81, which becomes a positive 6.81. And then I have a 3 milli times 8.25 times 10 to the minus 4. So I can add those two together. So I end up with a 3 milli times 8.25 times 10 to the minus 4th, and then a minus 1 times minus 1 becomes a plus 6.81 times 10 to the minus 7th. And then this shifts from e to the minus. So to solve this portion, I have to take 1 plus j omega 8.25 times 10 to the minus 4th, and I need to change that into the form, let's make this small enough you can read it all. I need to change that into the form which is a plus j omega. And so to do that, I need to divide by 8.25 times 10 to the minus 4th. And so a plus j omega, in this case, will become 1 over 8.25 times 10 to the minus 4th plus j omega. And so that's why I end up with a minus 1 over 8.25 times 10 to the minus 4th. And then it shifts by 3 milli, so t minus 3 milli, u of t minus 3 milli. And then the other term is 6.81 times 10 to the minus 7th, e raised to the minus, oh, I apologize, I miswrote this. So this is a minus here because there is a plus in front of the e. So this is a minus 6.81. And then minus 1 times minus 6.8, that one doesn't have a time shift. So that becomes the 6.81 times 10 to the minus 7th raised, and then e times raised to the minus 1.825 times 10 to the minus 4th t times u of t. And then I need to do the next term, which is number 4, which means 2 over j omega. So I have to use a half here. And I do the same thing. I'm going to combine this term and this term. So I have 8.25 times 10 to the minus fourth, and then I subtract off the minus 3 milli, and then that becomes a sine t minus 3 milli, and then I have the minus 1 up here, and so that becomes this term of the minus 8.25 times 10 to the minus fourth over 2 sine t. And then I have number 6, which is going to be this one. And I have one term that is shifted and one that is not. So the minus, and for this one, it's a minus 2 over omega squared goes to an absolute value of t. And so that gives me a half t because I have a minus 1. So that becomes a half absolute value of t. And then the e to the minus j 3 milli w over omega squared is the time shift. And then there's no negative there, so I have to do a negative 1/2 and then t minus 3 milli. All right, this concludes the solution for this Fourier analysis. Thanks for watching.